Hello everyone, myself E. Sunil. I am Assistant Professor, Department of CSAML, St. Martin Engineering College. Today, explain about the subject as database management system. In the topic is normalization and normal forms. So first of all, what is normalization? Okay, so normalization means it is a database design technique we can use for reduce the redundancy. Okay, so we have to reduce the redundancy in database. When we are creating the database, in that database we have some redundancy is occurring. So for first thing, what is redundancy? So I will show the example, then you can clearly understand about the redundancy. Okay, so here you can see I have one table, student table. Here we have attributes like student ID, student name and age. So in this table we have three attributes, that is student ID and student name and student age. Here you can observe clearly. Okay, so here student ID 1 to 1. Okay, student ID 2 times repeated, so it means it is a redundancy. So clearly we can tell redundancy means it will be duplication of the values. We have to reduce that duplications and we have to create the table as a database. That is the redundancy. So here you can observe, so if the SID is primary key, so here we have to take the student ID is a primary key, to each row you can use it, remove the duplicates as shown below. So this is the redundancy and this one is the redundancy table, final table. So we have to reduce that redundancy using these normal techniques. So whenever we are using the redundancy, we have occurring some problems. So that problems errors will come. The errors we are calling as a anomalies. Okay. So errors we are calling as a anomalies. Data redundancy means it having the same data at multiple places. Data redundancy means same data at the multiple place. It necessary to remove the data redundancy. Why? Because it causes the anomalies in the database. We have to must and should remove the redundancy. Why? Because it is anomalies. Anomalies means error. It will be create the error. The main reason of normalizing, the main reason is using to normalizing, that relation is to remove this anomalies failure. That reason is to using remove the anomaly failure to eliminate the least data redundancy. The main normalization we can use to remove the errors, that relation to remove these anomalies. When you have to failure occurring, so we can use eliminate this redundancy. Otherwise it causes the integrity and other problems. Integrity means the data will not be showing as a nice. Okay, next I will explain about the anomalies. What is anomaly? Okay, so what is an anomaly? Anomaly means it is error. So anomaly is the relation model referred to inconsistent or errors that can arise when working with the relation data. When we are working with relationship and the databases, that anomalies is using to refer to inconsistency. Inconsistent means it is not using the properly, and that time we have to got errors that can arise. This we can use that relation databases. So we have some types of anomalies. We have three types of anomalies, that is insert anomaly and delete anomaly and update anomaly. These are the main anomalies, main three errors occurring when you are using the database. Okay, so we want create the database, we can use insert command and we can use the delete and update. So insert anomaly means I will explain. So here you have to see, so anomaly in insert anomaly, this occur when we are not able to insert the data. It means we are not able to insert the data. That time insert anomaly will be occur, and it has to data because the columns may be missing the time of insertion. Okay, sometimes we have to insert the data, extra data we have to insert into that database. So that time the anomaly will occur. That time the error will occur. That is insertion anomaly. Okay, so for example, here you have to see. So here we have a table. Okay, I will show the example, then you can clearly understand what is insertion anomaly. Okay, so here you have to take, we are taking the database file. So I have student table. So here student having the student ID and student name and student branch. Okay, so here we have three attributes. So here I have three values 1, 2, 3. Through three IDs I have. First ID is Raju. His name is Raju. And second ID, his name is Ramu. Okay. Third ID, his name is Roshan. Okay. These are the three values I have in the student ID. And branch is CSE and ECE and data science. Okay. So these are the three values and three attributes I have. So here I want to insert the value. Which value? So I want to take fourth value. Okay, I want to insert one value. Fourth value is Ramesh. Okay, the fourth value insert Ramesh, and he is a department of IoT. So and his age is 26. Okay, so here I have four. I want to insert the Ramesh value, but it will got four attributes. So in my database, it will allowing three attributes only. So we want to insert this fourth value. That time errors will come. What error? So age. Here error is age. The age attribute is not in our database. Then we can't insert the data in that database. That is the insertion anomaly. Okay. Then next go to update anomaly. Update anomaly means when we want to update the data, when we are using updating some values, we cannot update. This occur when deleting one part of the data delete and other necessary information from the database. When we are update our value, that same data items are repeated with the same value. The same data items will be repeated. So we can't repeat the same values in the same table. That is the update anomaly. Next, coming to delete anomaly. Delete anomaly means this occur when the deleting the data. When we want deleting data, one part of data delete, other necessary data will be information will be loose. So that is the delete anomaly. So here you have to see this table. In this table, I want to delete the Roshan data. Okay, this Roshan data I want to delete. So the Roshan data will be deleted. Remaining necessary data will be deleted from this database. That is the delete anomaly. Okay. So next normal forms. We have to reduce this redundancy. We can use normal forms. Okay, we can reduce this redundancy. We will use data. Okay, one second. So here when we are using normalization, we have three types of errors. That three type errors we are calling as anomalies. That is insertion, update, delete. Okay. So when we are using that insertion, update, delete, we have to solve this anomalies. We can solve these anomalies. We can use the normal forms. Majorly we have normal forms of 6 types. Okay. Majorly we have 6 types of normal forms. That I will explain what is normal form. Okay, normalization works to series of stages. The normalization will be works to series of stages called as normal forms. The normal forms applied to this table to be particular norms, and from it is that satisfy rules. Particular norms will be satisfying those rules. Okay, here we have types of normals. So we have 6 types of normals. That is first normal form. We can call it as a 1NF. Okay. Second normal form, we can shortly call it as a 2NF. Third normal form, we can call it as a shortly 3NF. So main important is bias coded normal form. So another BCNF, we can call it as a BCNF. Fourth normal form. So the fourth normal form, we can call it as a 4NF. So shortly we can call every normal form. So why? Because we are using normal forms, it is working with the series of stages. The normal forms will apply to those tables to particular normal forms. From it is satisfying those rules. That's why we can use this normal form to reduce the redundancy on your database. Okay, we can use these normal forms. So I will explain first normal form with example. Then you can understand what is first normal form. Okay, so I will show the first normal form. So here, this is the first normal form. We can shortly call it as a 1NF. Okay. So a relation will be in first normal form if it is contain atomic values. It contain atomic values. A relation will be in a 1NF. A relation will be using first normal form. We can use atomic values. Only atomic value can be performed on this first normal form only. It means what is atomic value? Atomic value means it is a single value. Atomic value means it is a single value. Okay. If states that an attributes of table contain hold multiple values, it must hold only single valued attributes. Okay. The first normal form will be supported only single value. It is not supported to the multi values on that database table. So first normal form disallows the multi value attribute. Strictly it is not allowing the multiple value attributes. Okay, you can remember this point. First normal form disallows the multi-valued attributes. Simply we can say what is first normal form means it will be using only atomic values. Atomic values means single values only. When we have to use, if having multiple values on the database, it will be not supported. That is not a first normal form. Okay, so here I will show the what is first normal form with example, then you can understand what is 1NF. Okay. So observe this table here. We have to follow some rules on the first normal form. Okay, we have to follow some rules. Rule number 1. Here you can use the table. I have table. So here you observe clearly first attributes that we are calling as a column 1, second attribute that we are calling as a column 2. So when you want to use first normal, you have to remember these rules. Okay, you have to compulsory remember these rules when we are creating first normal form. So each column should contain atomic value. You will check that that attribute having atomic values or not. Okay, so here you can observe A, B, C, D. I have 4 values in the first attribute. So it is normal form. Okay, it is satisfied with first normal form. So you can observe second attribute. It is not satisfying with first normal form. Why? Because you can all observe this example. So here I have X and Y. Okay, I have X and Y value, and the second row double and X. So it is not satisfied. You can remember this rule. Each column should contain only atomic value. Atomic value means single value only. So in this attribute, it will be must satisfy with single values. This attributes must not satisfy with the single value. Multi values are here happen. That's why it is not a first normal form. Okay, you can see entire like xy and wx violate the rules. That is violating the rules. You have to remember rule 2 also. A column should contain values that are the same types. The column should contain only same values or the same type of data. So here date of birth is there. When you are creating first normal form, you have to remember this rule 2. A column should contain values that are not same type. Same type we can't use on the table. Okay, here data DOB attribute is there, name attribute is there. So you can observe these all are same values only. In the last value is different. So the value type is different. We can't insert this type of values in the first normal form. Okay, do not enter mix different types of values if any column. We can't use this different types of values in that column. Okay, so we can observe here name column is there, name column and date of birth column is there. So here it is satisfied, and this row is also satisfied, this row is also not satisfied, but this is not satisfied. Okay, that's why it is not using. Next, you have to remember rule 3 also in first normal form. So here each column should have a unique name. So compulsory to have unique name. Like this you have to prepare when you create the first normal form. Okay, it's must showing the data saved as the same name. So we have to change the name. It will be using SQL query. You can easily fetch the data in any from the table, like this you have to create. So you have to remember these 4 types of rules on when you are creating the first normal form. Okay, now you can understand easily. Okay, now next we can go to second normal form. So this is the first normal form. Must you have to remember 4 types of rules. So I will show first normal for another example. Then you can clearly understand what is first and normal form. The following course contain relation is not in a first normal form because contain attribute contain multiple values. You can observe this table. First attribute having the course. Okay. Second attribute having the content. So here first attribute course having the programming and second course is having the web. Okay, you can observe second attribute here. Second attribute having Java and C++ code. Okay, so here multiple values are happen. So it is not in a first normal form because the content attribute contain multiple values. We have to separate that multiple value, then must it will be satisfied with first normal form only. So the table must satisfy with the first normal form. You can observe here unique values is there. See, multiple values are not inserted in the attribute. So it is satisfied with first normal form. Then you can observe this second attribute. Here also single values are inserted in that attribute. So it is must satisfied with the first normal form. Okay, the below relation student is satisfied with the first normal form. So you have to remember these rules. The official qualification in first normal form, each attribute name must be unique. So you have must and should remember these three rules. So that is each attribute name must be unique. When you are creating or you have to convert a normal form, first normal form, you have to remember this rule. That is each attribute name as a unique and attribute val must be single and you have to row must be unique. When you are observing that row, it will be must be using, and additionally you can use using primary key. First attribute always having the primary key. That's why you can choose a primary key. Next, reminder. You have to remember this point must and should. Why? Because the primary key is unique, not null, unchanged. When you are taking the primary key, that is not be unique. Okay, the primary key, that attributes must not be using as a unique and it will be as a not null. Don't insert not null values and don't change the values. That is a primary key, can be either attribute or combined with attributes. So next we will go for second normal form, 2NF, second normal form. A relation is in 2NF. A relation is in second normal form. It means we following condition satisfied. When you are convert that database table into second normal form, it will be must be using with these conditions. Why? Because first condition is the table should be in the first normal. First you have to check the table is there in first normal form or not. That is your first point. First point, you have to check the table will be first normal form or not. What is first normal form? Atomic values. First normal means it is an atomic value. Atomic values means only single values will be there in that attribute. That is the first normal form. So you have to must and should check the first normal form is or not. So next, there should be a partial dependency. There should be a partial dependency. Partial dependency. I will explain what is partial dependency. Then you can clearly understand what is partial dependency. Okay. So with example, I will explain. Then you can understand what is partial dependency. Okay. This is the second normal form. You have to must follow this condition. Okay. I will show the example. Then you can understand what is the partial dependency, what is the not partial dependency. You have to check it is no partial dependency. Okay. Next, here you have to see if a non-prime attribute, if a non-prime attribute can be determined by the part of the candidate, by the part of the candidate key in a relation. In that relation table, that non-prime attributes can be determined by the part of the candidate key only. That is a relation and it is known as the partial dependency, and it is known as a partial dependency. Example for partial dependency means suppose there is a relation R. So here the relation we have table name as a R, that is R is a relation, that is table name with attributes as A, B and C, with attributes having A and B and C. So here R is a relation, the attributes will be having the A, B, C. So where A, B is a candidate key, here A and B is candidate key. So that is a non-prime attribute. Okay. C, so that is a prime attribute. C is a non-prime attribute. So we have to take that C as a non-prime attribute. Then A, B are the priming attributes. C is the partial dependency. Why? Because A part of a candidate key, C is a part of non-prime attribute. So it is not in a partial dependency. So it is partial dependency C, A is a candidate key. You can see this example, then you can clearly understand what is the partial dependency. Okay. So here I have the student table. In that student table, first attribute is rule number, second attribute is first name and student, then last name of the student, course code. So this is my student table. So here prime attributes means the attributes which are used to prime a candidate key. that is used to prime a candidate key are called as a prime attribute, are called as a prime attribute. So non-prime attribute, the attributes which is do not from a candidate key are called non-prime attribute. The candidate which is do not a candidate key, that is the non-prime attributes. So here prime attribute is using the attribute as non-prime attributes, first name of the student. So the roll number and course code is the prime attributes, and non-prime attributes are the first name of the student and last name of the student. These are the prime and non-prime attribute. I will show the example, then you can understand clearly what is partial dependency, what is non-primal dependency, how we are creating the second normal form, how we will convert the second normal form, normal database to the second normal form. Okay, here if student project relation, that prime key attributes are student ID and project ID. So in this, these are the four attributes I have in my table. In my table, four attributes. First attribute is student ID, second attribute project ID, and the third attribute is student name, and fourth attribute is a project name. Then you can observe here, so the student project relation, that prime key. So here student ID as a primary key. I will take this first attribute as a primary key. So that primary key must be in the not atomic values or single values. Okay, project ID. Project ID is a second candidate key. So these are student ID and project as the key candidate keys. Okay, according to the rule, non-key attribute. Non-key attributes are student name and project name. Project name can be identified with the project ID. We can identify with project ID. We can use student name and project name. Okay, it is dependent, independently depend on the student ID and project ID. This is called as a partial dependency. Okay. Then here observe that first attribute is using student ID. Then you have to identify student name and student project ID and project name. So here what happened? Partially it is dependent by the student name for student project ID and student ID. Compulsory it will be identified. So it is a partial dependency which is not allowed in second normal form. The partial dependency will not allowing on your second normal form. You have to remember the second normal form must not allowing the partial dependency. Okay. So then next, candidate key. Candidate key is student ID and project ID. Non-prime attributes are the student name and student name, project name. So we broke the relation into two as dispatching. So here we have to break in the two relations. Okay. That main table we have to break and like as a two tables. First table as student ID, student name, project ID. So you can observe here the student ID depended on the student name, and the it will be depend on the student ID. It will be not dependent on other one. So that is the student table, that is our not partially dependent. Okay, so here no partial dependency occurring on your table. Okay, observe this project ID, then you can identify the project name. So it is not depend on the project ID. Then here no partial dependency happening on this table. That's why we have to broke that main table into two types of tables. So here two types of tables, then it will must satisfying. So what is our rule? So what is our rule? We can, when we are inserting the when we are converting in normal table into second normal form, you have to must remember first point, you have to check it is the first normal form or not. First you have to check it is the first normal form or not. Second, that is not allowing the not primary key, that is not allowing in partial dependency. Okay, you have to remember this 2 points. You can observe this table. Here I have course ID, semester ID, name of the student and course name. So here we have four attributes. The first attribute having the course ID, second attribute as semester ID. So here semester ID depend on the course ID. So here partial dependency happening. What is our condition? It is not using our, it is not depend on the primary key. Okay, the course name depend on only course ID, a part of primary key, not to whole primary, that is course ID, semester ID is called as a partial dependency. It is called as a partial dependency. What is the solution? The solution you have to use, remove course ID and course name. You have to remove course ID and course name. You have to separately create the table. Okay, that is together to create the new table. So then you can understand what is 2NF. Okay, you can understand what is 2NF continuation. Here we have to separate the two tables. First table I have course name and course ID. The course name is dependent on the course ID only. Here no partially dependence occurring. So that is second point is matched. So first point is you have to check must it having the atomic values. Okay, that is must satisfying with the atomic value. The first attribute must having the single values only. So you can observe here done. So one mistake is there, you can observe it is still not in first normal form. It is still not in the first normal form. Why? Because multiple values are inserted in this course ID. Check here IT101, IT101 double time, two times it will be repeated. So that is the database course, and first attribute, second attribute are multiple values there. So it is not satisfied with the first normal form. So what is our second normal form condition? It must be satisfied with the first normal form and no partial dependency on that occurring. Okay, so here you can check this table, and here also this is second table. So here multi values are happening, so it is not satisfied with the first normal form. You have to create another table. So check here, no multiple values, only single values inserted. So here it is satisfied with the first normal form and no dependency is there. So here observe the single values not there, and the student semester ID will be depend on the course ID, customer ID, course ID. So number of students are so repeated, 25 twice repeatedly. So that's why it is not the condition is not satisfied. Partial dependency is there. So it is not partial dependency table, and this is a partial dependency. Okay. Finally, our table is this one. This is the second normal form. Okay. Then it is the satisfied. Next one is third normal form, 3NF. What is 3NF? The relation is in third normal form. It will be must satisfied with the following condition. What condition? We have three types of condition in the third normal form. So it should be in the second normal form. Compulsory, it should be in the second normal form, and it should not have transitive dependency. It should not having the transitive dependency. All transitive dependencies are removed to the place another table. All transitive dependency it have to remove. I will show the example, then you can understand what is transitive dependency. So you can observe here. Let's take an example to understand to better. So here book, author, age. We have three attributes. Okay, in that we have Vidwan, Harry Potter, Dying of the Lights. These are the books. Okay, then authors are George R. Martin, J.K. Rowling, and George R. Martin. So these are the authors, and his age is 66, 49, 66. Okay, here book author, it will be known as a, when we want know the book, we can know the author. Okay, when we know the book, we can know the author. So know that author's name. Okay, then author does not using the book name. Author does not using the book name. So author having the author age. Therefore, as per the rule, transitive dependency means book, author, age should hold that make a sense, because if we know the book name, we can know the author's age. Okay, we can know the book name, we can identify. So we find that above student details relations, student ID in the K only primary key. Student ID is a primary key here, and we find the city can be identified by student ID. We can find the student ID. We can use student ID as a primary key. Then we can identify the city with using student ID only. Okay. Then after, neither zip is a super key. Okay. Here the zip, if you want take a super key. So our third normal form condition must be it having the super key. So here city as a primary attribute. City is a primary attribute, and zip is choosing for the super key. So additionally, student ID is depend on the zip, and city also depend on the ship. So here what happened? Two values depend on the student ID. So that is the transitive dependency. Transitive dependency means it will be not using multi-valued attribute depend on the single primary key. That is the rule. So these are the student details for the third normal form. So we can separate this city and zip for another table. We can separate that city and zip. We can create another table. Student details. So here you can observe student ID, student name, and zip. So it is not having the so these are the third normal form. Okay. Thank you for listening my lecture. Thank you everyone.